In this video, you're going to learn about the other types that come with GraphQL. It is not just strings, despite what you might think based off of what we've actually used so far. There are actually 5 main types that I want to talk about in this video. Right here, we're going to list out all 5. And you can always refer to the PDF guide for this video to get the exact list so you don't have to write all of this down. The first type we have is the string. The string type, as we've already seen, stores our string-based data. We also have the Boolean for storing Boolean values. This is great for things like an isPublished field, where the value is either the Boolean true or the Boolean false. In GraphQL, we can also represent numbers, and there are 2 types for that. First up, we have the int for storing integers. So for storing whole numbers, like your age, 27, or something like the number of products you have in stock. Maybe you have 14 somewhere in the warehouse. After int, we have float, another way to represent our numbers. This is great for numbers with decimal points, like a GPA, 3.17, for example, or something like a ratings system where a product has been rated 4.7 stars by customers. Last up, we have the ID, that is capital I, capital D, and this is a bit unique to GraphQL. It's used to represent unique identifiers. In the end of the day, it is very similar to a string, but we'll explore the differences as we progress through the course. Now, these 5 types are known as the 5 scalar types inside of GraphQL. A scalar value is just a single discrete value, so a scalar type is a type that stores a single value, whether that value is a string, a boolean, an int, a float, or an ID. This is the opposite of a non-scalar type like an object or an array, which is a collection of discrete values. So with an object, we have many properties. With an array, we could have many elements in that array. We'll be covering objects and arrays very soon. For the moment though, in this video, I just want to focus on these 5 types, and we're going to do that by setting up 5 queries, 1 for each type. Let's go ahead and remove our existing 4 queries from our type definitions and from the resolvers down below, and we're going to set up 5 new ones. And all 5 of these are going to be things that could describe a person. So for example, we're going to have an ID, a unique identifier for that person, and the type is going to be the ID type. So uppercase I, uppercase D. Now for almost all of the fields we set up, we are going to want to use the exclamation mark, saying that this is something that should always return an ID, as opposed to being able to return null. Now after ID, we might have something like name, and in the case of name, we could use the string type we've already explored before. After name, let's say we want to represent the person's age as an integer. So right here, age, colon space, uppercase I int with an exclamation mark on the end. Next up, we can use a Boolean to represent whether or not that given person is employed. So right here, we could set up the field employed. I could have its value be a Boolean, and we'll use an exclamation mark to make sure we always get a Boolean back. You're either unemployed or you are employed. Down below that, we are going to have our final value, and this is going to be the GPA. Now the GPA is going to be stored as a float because my GPA could be something like 3.17, for example, and I'm actually going to leave the exclamation mark off. If I'm not a student, I'm not going to have a GPA, so it's okay if I get null back. This basically says it's okay if I get null, but if I am sending back a non-null value, it has to be a float. So we have all 5 queries set up. Let's go ahead and create resolvers for each. I'm going to start with a method for ID. After ID, we have name. After name, we have age. Then we have employed, our Boolean value. And finally, we have GPA, the one that is optional, so we could return null from here if we wanted to. Now, for the moment, you'll notice that we have individual resolver methods for individual properties on something like a user. This is only temporary. Once we learn about our custom types, where we can actually model a user, a post, a comment, or whatever else makes sense for our application, we'll be reducing the number of resolvers, so this is just a temporary thing. We will address this shortly. For the moment though, to mess around with all of the scalar types we have access to, let's go ahead and return what each expects. So in ID, I am going to return a string ABC123. I could also choose to return a number like the number 12, for example, but in the end of the day, that will get converted over to a string, so it'll look more like this. I'm going to stick with an actual string ABC123. For name, we are obviously returning a string, something we've done plenty of times before, not much to say there. For age, we are going to go ahead and return an integer, so I'm going to return 27. For employed, we want to return a Boolean, so I would return true if I was employed, or false if I was currently unemployed. I am self-employed, which is definitely a type of employment, so I'm going to go ahead and return true. Last up, we have our GPA. Now with the GPA, yes, we could return something like 3.1, perfectly valid, a perfectly valid float. But we could also choose to return null, because remember, for this type definition, we left off the exclamation mark. This is saying, I expect a float back, but it would also be fine if you gave me null. This is saying, I expect a Boolean back, and because of the exclamation mark, it's saying you have to return a Boolean. You can't return null. Since I currently don't have any sort of GPA, I'm not in school right now, I am going to go ahead and return null. Now that we have all 5 set up under both our type definitions and our resolvers, let's go ahead and save the file, restart our server, and test things out. I'm going to shut the server down. I'm going to start it up once again. Over inside of the GraphQL playground, I will give things a quick refresh just to update that schema, and we're going to update our query. I want ID. I'd like name, spelled correctly, of course. I would also like age. Then we have employed. And finally, we have GPA. I'm going to fire that query off, and what do I get back? I get back all of the correct values. ID, we have our string. Name, we have Andrew. Age, we have the integer, 27. Employed, we have true. And for GPA, we have null. For GPA, remember, we could have also returned a float. So over here, I could return something like 3.01. That would get the job done. If I save the file and restart the server, we can actually query for that data. So it's perfectly fine to have null, but as we can see now, it's also perfectly fine to actually return that float. So there we have it. These are the 5 scalar types that we can work with inside of GraphQL. Now, as your challenge for the video, I'd like you to go ahead and add a couple more into the mix. Up above, I have a few comments for what I'd like you to do. So right here, you are going to be creating a query definition, and a resolver for each of these 5 properties. Now, in this case, let's say we're modeling an e-commerce store. So we have titles for our products, we have prices, release years, ratings, and whether or not that product is in stock. And we want to represent all of these using some of our scalar types. So the title, for example, is going to be a simple string for the product name, and this one is going to be required. You have to have a title. For the price, we're going to say this is a number represented as a float, so the price could be 9.99. We're also going to have an optional release year represented as an integer. So whether or not it makes sense for your product is up for you to decide, because it is, in the end of the day, optional. We also have a rating, which is a number stored as a float. Your rating might be 5.0 or 3.64, and it's also optional. So when your product first goes up, we're not going to return a rating like 5 or 0. We're going to return null, just saying there is no ratings yet. Last up, in stock, that's a Boolean. If it's true, the product's in stock. If it's false, the product is not in stock. Now it's up to you. How do you want to approach this? You are more than welcome to keep all of these in place and then add these alongside. You can also go ahead and just clear all of your queries and all of your resolver functions and build up from scratch. Either way, it gets the job done. So take some time to knock this out and test your work. Save the file, restart the server, and actually query for all 5 of these over inside of the GraphQL playground. All right, pause the video, knock this out, and when you're done, come back and click play. How'd that go? Let's kick things off by setting up our query definitions for all 5. So first up, we have title. Title is going to return the value of a string. It's required, so I'll toss an exclamation mark on the end. We also have price. Price is going to be stored as a float, and price is also not optional, so I'm going to be putting an exclamation mark on there too. We then have the release year. The release year is completely optional. When it is provided, though, it's going to be represented as an integer, so right here, int. Next up, we have the product's rating. The product's rating is stored as a float. This is also optional. So I'm going to type float with no exclamation mark at the end, allowing null to be the value for rating. Last up, we have in stock. A product either is or is not in stock. This one is going to be a required Boolean. Excellent. So we have all 5 type definitions. Now we can actually move on to the resolvers down below. So we're going to start off with title. And for title, I'm going to return some sort of product name. I'm going to return a string, and I'll just use a book on my desk as the product. That is The War of Art. It's a great book about your inner creative battles and overcoming that stuff to get back to work and get productive and release the stuff that you want to release. It's a great book. After the title, we're going to set up the price. Now for the price, this could be anything. I don't know what this book actually cost. Let's just go ahead and say it costs 13 bucks. So I will return 12.99. After the price, we have our release year. Release year. I could dig into the book and see what the release year is, but I'm going to go ahead and just return null, since remember, the release year is completely optional, so returning null is valid. After release year, we have our rating for the book. I definitely enjoyed this one, so let's say that it has a 5-star rating. So right here, I'm going to return 5. The last one, whether or not the book is in stock. In stock, I'm going to go ahead and say this book is in stock, so I will return true as opposed to false for the book being out of stock. Now we have all 5 set up. We can remove the challenge comments. I'm going to go ahead and save this file. Down below, we will restart things from the terminal, and then we're going to query for all 5 in GraphQL Playground. If we get the correct data back, we're all done. So right here, we're going to change up that query a little bit. First up, I will refresh the page to grab the latest schema. I'm going to access the title. I'm also going to grab the price. I'll grab the release year, even though we know the release year is going to be a null value. After that, we have the rating for the book, and then whether or not the book is in stock. If I execute that query, what do I get back? I get back all of the data that I just set up. We have our title, The War of Art. We got our price, $12.99. We don't have a release year. We have our 5-star rating, and the book is indeed in stock. So there we go. You now know about all of the 5 scalar types that we can work with inside of GraphQL. What we're going to cover next is how we can create custom types to model the real-world things that make up our application. So in this case, we might have a product custom type for all of these 5 fields. In the case of the fields we had earlier, we would have something like a user custom type. And that's going to make it way easier to maintain and scale our applications. No longer will we need 5 functions for 5 simple pieces of data. We'll be able to return everything that a custom type has with just a single resolver. Now, we're going to get to that in 2 videos' time. In the next video, which could be considered something like a bonus, I'm going to show you how we can automatically restart our server whenever we make any changes to our application code, so we don't have to manually restart it every single time we make a change. Let's go ahead and jump right into that.